Assalamualaikum and a very good day everyone. We are from Group 6, Section 2, and today we will present to you our first assignment for Smjm 1023. Next, we have table of contents. Firstly, we have introduction and problem description. Second, we have methodology, which includes overview of the method we are going to use and calculation. Next, we have result and discussion. And lastly, we have conclusion of the topic. Next, we are going to present to you our group members, which consists of 5 people. The first one we have Nick Cherry. The second one is Nur Akila binti Nordin. The third one is me, Nurin Idina binti Azizi. And the fourth one is Precious. And the fifth one is Nurul Fatiha binti Jamal. So for the first assignment, we choose question 12, and the introduction is according to Newton's law of motion of cooling, the warmth loss of a body is because of thermal distinction between each of the system and its surrounding. Newton's law of motion, also known of cooling, is also followed in heat transfer constant for pressurized air or high pressure fluid cooling. Convection cooling also is usually stated as Newton's law of cooling. Newton's law of motion or cooling also applied once the warmth transfer constant is free length or nearly thus of the distinction in temperature seen between object and its surrounding.
Okay, now I will talk about the problem description. Our group choose to answer the question 12. The question 12 states a cake was baked and after it was cooked, it was taken out from the oven to be cooled on a table at room temperature 21 degrees Celsius with an initial temperature of 145 degrees Celsius at 10 a.m. So the temperature should be dropped to 90 degrees Celsius after 20 minutes. This can be conducted as the equation below. dt over dt equal negative k in the bracket t minus ts. From that equation, T will act as the cake temperature at time t, and the Ts will act as the surround, which is the room temperature, and lastly the K will be the cooling constant. So the question is, what is the suitable time we can eat the cake if the temperature reaches 40 degrees Celsius? Okay, so from the equation on the previous slide, this matters is really analogous to the Newton's law of cooling. So for our information, the Newton's law of cooling stated that the speed of the warmth loss of a body is directly proportional to the distinction within the temperatures between the body and its clothes. So the application really applicable to solve this type of question. It is really important because we can use the application to our daily life. Another example, mostly forensic use the application to assume the initial time of death of a corpse.
For the methodology, the temperature of item can be derived by using differential equation when an object has a temperature greater than ambient temperature. It cool according to Newton's law of cooling or heating state. The body temperature changes at rate proportional as in an equation below. dt over dt might equal to negative k t minus ts. which is K is constant, T is current temperature, and T is surrounding temperature. However, when the items are heated than surrounding, the T minus Ts is greater than actual, so the dt over dt is huge and negative. So, the item cools quickly when the item is just slightly warm than ambient temperature. The T minus Ts is narrow and positive, so that will cool slowly. The technique can be used to solve the equation dt is by using separable method, which indicate the constant K, temperature T, and temperature Ts at particular time T. This is general equation, and when you use the separable method, it will become over T minus T s dt equal to negative K dt. So, after we got this equation, we need to use integrating with respect to T. Multiply and rewrite, we will get the general equation of Newton's law of cooling, which is T equal to A exponent negative KT plus Ts, which is A is exponent C. So, since it is constant, we rewrite to A. So, the equation that we choose for this assignment is: a cake was baked, and after it was cooked, it was taken out from the oven to be cooled on a table at room temperature 21st degree Celsius with an initial temperature of 145 degree at 10 am. Suppose the temperature of the cake dropped to 19 degrees Celsius after 20 minutes. The temperature of the cake is covered by dt over dt equal to negative K T minus Ts, where T is the temperature of the cake at time T, Ts is the room temperature, and K is the cooling constant. Determine a suitable time to eat the cake if an ideal temperature to consume the cake is 40 degrees Celsius. So, from the equation, we know that the Ts is 21st degree with an initial temperature of 145 degrees Celsius at 10 am. From this sentence, we know that when T equal to 145 degree, T time is equal to 0. And we also know that when the temperature of the cake drop to 19 degrees Celsius, we know that the time is equal to 20 minutes. So, from the information we got from the question, we can find the time when the temperature at 40 degrees Celsius. So let me check the solution. equation. We use the dt over dt equals to negative k t minus ts. By using separable method, we got the equation 1 over t minus ts dt equal to negative k dt. To solve this separable method, we need to integrate both sides. After integrate, at the left side, we will got ln, and at the right side, negative kt plus c. C is constant, and we don't want the ln at the left hand side. So we move to the right hand side, and it will be t minus ts equal to a exponent negative kt. So the general equation, we only want t. So the ts will remove to the right hand side. The equation will be t equals to a exponent negative kt plus ts. From this equation, we can find the a. When that we know that we have the information that when t equals to 1, 4, 5, the time is equal to 0. So from this information, we rewrite into this equation, and we know that the a is equal to 1 to 4. So the new equation is t equal to 1 to 4 exponent to the power of negative kt plus ts. So from this equation, we also have another information, which is when t is equal to 90 degree and time is equal to 20 minutes. We know that we can find the constant k by substitute into the equation. We will get the constant k is constant k is 0.03. So we know the value of a is 1 to 4, and also know the value of constant k, which is 0.03. We can conclude that the new equation is t equal to 1 to 4 exponent to the power of negative 0.03 t plus ts. So the question wants us to find the time at t temperature equal to 40 degree. So we substitute the temperature into this equation, and we will find the time at 40 degree, which is time is 64 minutes equal to 1 hour 4 minutes. So we know that the time the cake move from the oven is at 10 a.m. So this 10 a.m. plus with this, we will get that the time ideal to reach 14 degrees Celsius is at 11:04 am. The time for the cake to reach 40 degrees is at 11:04 am.
Result and discussion. In this part, I will explain to you guys regarding the result and discussion of the topic. After we solved the question in the previous part, we found out that the best time to eat the cake is at 11:04 am. To obtain the result, first we must find the t using t equals to 124 e the power of minus 0.03 t plus t0. The situation in this question is similar to Newton's law of cooling that states the rate of the heat loss of a body is directly proportional to the difference of the temperature between the body and the surrounding. Newton's law of cooling general equation is T equals to AA to the power of minus kT plus Ts. This is the temperature against time graph. In the previous slide, according to the graph, we can see that the temperature drops significantly and rapidly in the first 20 minutes. After that, the temperature lowers slowly. It means that the cooling pace of the surrounding takes place faster at the initial period.
In a nutshell, the temperature difference between object and the surrounding that relate to Newton's law of cooling is when the greater difference between object and surrounding will become faster it's cool. Besides, the smaller difference between object and its surrounding, it will cool slowly. Since there was a large difference between the object and its surroundings, the temperature will decrease more than the room temperature. In this case, the Newton's law of cooling states that the temperature of an object changes at rate proportional to the difference in temperature between object and its surroundings. Here are some references that we use.